Alright, this video is for exam 3, page 3 and 4, section 1, and we will be starting. So this question is separated into many different parts. So let f of x equal x to the power 4 minus 6x squared plus 8x minus 3. And we also have it here in factored form, as well as some additional information that will help us later on. So, first part, A, find both f prime of x and f double prime of x. So, f prime of x is the derivative of f of x, which is going to be 4x cubed minus 12x plus 8. And f double prime of x is derivative of f prime of x, so it'll be 12x squared minus 12. And that is all for part A. Part B is to find the critical points. And so, in order to find the critical points, we will use f prime of x, because we want to see when our slope is going to be equal to 0, and the best way to find that is with f prime of x and see when the equation equals as 0. It's 12x. And the easiest way to see when the equation equals to 0 is in factored form. So we'll use this part of the equation as this part is the same as f prime of x. So we'll turn it into 4 times x plus 2 times x minus 1 squared, and we will see when this equation equals 0. So, as we can see, when these two, the inside of these two, when they are going to be equal to 0, the entire equation is going to be equal to 0. So, x plus 2 equals 0, and x minus 1 is going to be equal to 0. And now we solve for x for both of these. So x equals -2 and x equals 1. And so our critical points are at x equals -2 and x equals 1. Alright, and that is all for that part. Alright, the next part, part C, is a little bit trickier. So find the intervals on which f of x is increasing and the intervals on which f of x is decreasing. Use the first derivative to to determine and classify the critical points from part B as max, min, or neither. So what we'll effectively do is have f prime of x, and we'll basically have a number line to see when the graph is increasing or decreasing using the critical points right here. And we will effectively plug in values for f prime of x to see where at those points our graph is going to be positive or negative, because we know that at -2 and 1 our slope is 0, which means that before or after those points the slope is either going to be increasing or decreasing. So that's why we're doing plugging in values in between them. Let's see. So first we're going to see when x is less than 2. We're going to plug in -3. It doesn't have to be -3. It could be any value less than 2 for this part of the equation. So as we can see, when we plug in -3, this part of the equation becomes negative, and this part is negative. However, because we're squaring this part, this will suddenly turn into a positive. So we're going to have negative times a positive. And so in this part of the graph, our graph is going to be decreasing. We are also technically multiplying by 4, however, that one is a positive in front, and that's not going to be changing in any way, regardless of what we put, what our x is, so there's no need to include it. Next, we're going to do f prime of 0, as that's the easiest to calculate for me personally. Let's see. So right here, our value is going to be positive, and right here, our value is also going to be positive because of this squaring. So positive times a positive is a positive. So our graph is going to be increasing at between -2 and 1. And finally, at x is greater than 1, we're going to plug in f prime of 2. Our value is going to be positive and positive. And the squaring, it will keep it positive. So positive times a positive is positive. So as we can see, our graph is going to be decreasing from negative infinity to -2, and it's going to be increasing from -2 to infinity. So we will write this down. Increasing at -2, comma 1. And it's important to put that 1 right here because at 1 our slope stops increasing, because this is it when our slope equals 0. So almost forgot to mention that. Sorry about that. So yes, union 1 comma infinity, and our graph is decreasing at negative infinity, comma, -2. Now, in order to see where our max, mins, and saddles are, with a saddle is when the graph stops increasing or decreasing, but then after it stops, it continues to go in the same direction. So as we can see right here at 1, we have a saddle because the graph was increasing before, and after 1, the graph is also increasing. So it's our critical point is neither max nor min, is a saddle. Now, as we can tell, at -2, our graph is decreasing, but then once it passes -2, it starts increasing, which indicates that this part, that at -2 we have a local minimum. As when you imagine a graph decreasing then increasing, that is the lowest point. So local min at, we will put the let's see, what would be best? Well, the best would be to calculate where the local min would be. So we will calculate it by putting f of -2, and that will be equal to 3 minus 2, -2 minus 1 squared, if we remember from our original equation. Oh, it's third. Yes. Good thing I checked. And that is equal to -27. So our local min is at -2, -27. And now for our saddle. it's going to be at 1. And let us calculate where that saddle will be. So f of 1 of 3 plus 1 times 1 minus 1 to the power of 3 equals 0. So we have a saddle at 1, comma 0. And that is all for part C. Alright, so for part D, we are asked find all the possible inflection points for f of x. So in order to find the inflection points, we are going to be using f double prime of x and do similarly to C, find when the equation is equal to 0. So let me see. If I remember correctly, it's 12 minus 12. Let's double check. I'm correct, yes. And the easiest way to find this is to turn it into factored form. So there's a few ways to do it, but I think the easiest way is 12 times x minus 1 times x plus 1, because all these multiplied together give you 12x squared minus 12. So x minus 1 equals 0 and x plus 1 equals 0. So x will equal to 1 and x will equal to negative 1. Now, what we also need to do is to calculate where the inflection points are going to be. So we're going to calculate for f of negative 1. And f of 1 we already have. It's 0 because of our previous question. So it's going to be 1, 4 minus 6, 1 squared plus 8, 1 minus 3, which gives us negative 16. So our possible inflection points are at 1, 0 and negative 1, 16. Should probably flip the order just so we go from left to right in terms of value. Just labeling it so we know what this is. And that is all we have to do for D. Next up is E. Alright, so find the intervals on which f of x is concave up and the intervals on which f of x is concave down. Use the second derivative test to determine which of the possible inflection points from part D above are accurate inflection points. So similar to C, we will have f double prime of x. We'll put down a number line to see when it's going to be positive, which is concave up, and negative, which is going to be concave down for this case. And instead of doing it in factored form, which we do have, we're actually going to do it with our original equation, because we'll only have one variable to worry about, and it is, in my opinion, easier to see. So we'll do 12x squared minus 12. So at f prime, double prime, of -2, when we plug in -2 here, it's going to be 24 minus 12. So in this case, it will be positive. When we have f double prime of 0, we will have 0 minus 12, so it will be negative. And when we'll have f double prime of 2, we'll also have 24, so it will be positive. So we'll have concave up here, concave down here, and finally concave up here. Now, now we will also have to put it in let's see, sorry, I forgot the name is, but we'll also show on where the interval is by saying concave up at, let's see, soft bracket, -infinity, comma, -1, union, 1, comma, infinity. And then concave down at -1, comma, 1. And from what seems to be the case, it looks like, hold on a second. From what I could tell, it seems that both at -1 and 1, we have inflection points because our concave shifts at every interval, so it seems to be that our inflection point at, we're going to put down our values, -1, comma, 16, and 1, comma, 0. And that is all for part E. And now finally, part F, which will take the longest because part F asks us to accurately sketch the graph of f of x on given graph below. Be sure to clearly label any y-intercepts relative to extrema, inflection points, and horizontal/vertical asymptotes. Show all of your work to receive full credit. Alright, so first part is to find our x and y intercepts, because we haven't actually found them yet. So it seems to be that for y, and let's see, equals our original equation. So it's going to be equal to -3. So our coordinate is going to be 0, comma, -3. And for our x intercepts, we are going to have, let's see, probably best use the factor form, 3 plus x times x minus 1 cubed. And set them equal to, set this equation equal to 0. So 3 plus x equals 0, x minus 1 equals 0. So we're going to have an x-intercept at -3 and an x-intercept at x equals 1. So our coordinates will be -3, comma 0 and 1, comma 0. Alright, so let us label these points in our graph. So -3, 0 is right here. 0, comma -3. It's in terms of 10, so just say right about here. Seems to be the case. And then 1, comma 0. Alright, now we have our x-intercepts. Now we're going to put down our local minimum and asymptotes. So our asymptote, we know that at 1, comma 0 is our slant asymptote. We also know that at -2, comma -27, we have our minimum. So let's see, 28, 27. At right here, around this point, we have our local minimum. So, and we will look at how our concaves is. Our concave up, concave down, concave up, and where the graph is going to be decreasing and increasing. So, negative, positive, positive. So, for this first part, our graph is going to be decreasing from this to infinity, and at -2 is where it's going to stop. Then the graph starts to increase all the way up to 1, and then at -1 it starts to increase again. And let us label our points even more just to make sure we haven't done any mistakes. So -2, as well as the question asks us. So we're going to need to do this anyway. So -2, -27, local min. Let's see. Yes, our inflection points are also very important. So at -1, 16, we should have our inflection point. So let's see. Seems we've gotten into the correct one. So let's see. 12, 4, 16. Yes. At -1, comma -16 inflection. Right here, we're gonna label this as, sorry about that noise. We're going to be labeling as -3, comma 0 for x-intercept at 0 and at 0. At 1, comma 0. We're going to also label that as x-int and inflection point. Let's see. Are there any other points? Yes. At 0, comma -3, we're going to put our y-intercept. And that seems to be every single condition. We have concave up, concave down, and concave up. Our graph may not be accurate in some points, every single point, but we got every single important point, and we've labeled all of our, and we have the general shape of what the graph is going to look like. So, sorry, my bad. This isn't local. This is absolute minimum because our graph is going to be increasing from both sides. So let's go back up to where we said it was local min and change that to absolute because our graph is only decreasing during that part. So it will definitely be the lowest part. So I apologize for that. But yes, now our graph should be correct. All right, and that is all for page 3 and 4 for question 3. And that'll be it. Bye.